Hello, we are Team 7. Our names are Jessica Lee, Jenn, Choi, Yiying, and we will be exploring the IMDB movies. So our work process is that we initially collected the data, did the EDA on the data, cleaned the data, and had our questions, and trained those models in testing for those questions, and we have our outcomes. So some information about the data set is that there are approximately 3,200 rows and around 28 columns with movie titles, directors' names, etc. And we found it on GitHub primarily. So some interesting information on that data is that we noticed some key information. So the ranges span drastically from the profits being from zero to, or very close to zero to, millions of dollars, as well as the fact that some features have zero in them, and a lot of them, and that the average for the IMDb score is 6.5, that is actually different from the median that is 6.6. So we decided to graph out that information into data histograms. And what notice is that most of these features are not normal. They skew very much to the right. However, when we tried to normalize the data, the results were not substantial, and that data only clearly makes sense as a skew. So we decided to also look at the correlation matrix in this case, because our questions really relate to how the different features correlate with each other. So what we did was we looked at what was very highly correlated. So some things weren't important to us, such as movie Facebook likes and the cast total Facebook likes. We knew that would be very highly correlated. But we did want to look at the IMDb score and notice that the number of voted users is very highly correlated, as well as the movie Facebook likes and a couple of other factors. So what we did was we cleaned the data, replaced the off lettering and the wrong values. Then we removed all the years before 2007 because we noticed that because we had movie Facebook likes, a lot of old movies did not have any pages or any Facebook likes at all. And then we cleaned the data so that the data could be used to answer each of the chosen questions.
With the IMDb movie dataset, we wanted to be able to predict whether the movie was successful. We broke this question into two parts, whether the movie will be successful based on the general audience or whether the movie will be successful financially. First, we'll look at the question whether this movie will be popular to the general audience. To predict whether it will be popular, we use IMDb ratings. We wanted to use the IMDb ratings to determine the value of the movies. With our continuous variable, we scaled it from 0 to 1. Some of our continuous variables were actor 1 Facebook likes, movie Facebook likes, number of faces in poster, and etc. We also one-hot encoded our categorical variables. Some of our categorical variables were movie director name, movie title, the content ratings, and things like that. However, after one-hot encoding all the categorical variables, it was overcomplicating the model. So as a result, our performance level was very poor. So we ended up dropping these features. However, we kept our genre encoded, one-hot encoded feature. Our genre feature had multiple genres for the movies, so we had to one-hot encode the individual genres manually. Our first model was regression, and we used cross-validation to improve our RMSE score. We used linear regression, decision tree, and random forest. After 10K folds of cross-validation, the mean RMSE for linear regression was the greatest by 0.953, and the decision tree lowest by 1.259. The results were not as accurate as we planned, being below what we were expecting. Most of the predictions were 0.9 to 1.3 ratings far from the actual rating. So we tried modeling our IMDb rating in a different model. We used classification this time. We used logistic regression, decision trees, and random forest classifiers. We rounded the IMDb ratings to a whole number to represent them from as a class from 0 to 10. Sorry. This resulted in a higher accuracy rate in general. Decision tree had a 34.1 accuracy rate. However, random forest had a very poor accuracy rate of 6.2. Decision tree had the best accuracy rate and the lowest misclassification error. However, the model still didn't perform as well as we expected it to be. So we further extended our model and used sentiment analysis to improve our model.
We used the bag of words method, and we used the models of multinomial naive Bayes and complement naive Bayes with the results of accuracy down below. So how we did that was we initially cleaned the data to make it so that we can merge it with another data set we found on Kaggle that had descriptions. We merged it on the title names, and then after that we assigned whether or not it would be a satisfactory movie to watch based on the IMDb scores median. And from that, we really vectorized each of the words. We noticed that the vectorization worked actually best with just vectorizing on one rather than two words, like two phrases and such. And then we got the following metric for our accuracy score. But of course, we had to do cross validation. So in the end, we got 56% as our accuracy rate, which is much higher than any other of the classification or linear regression. And we noticed that multinomial naive Bayes was the best model to use for that.
The second question is, would this movie be financially successful? In the previous question, we predict the rating of the movie, but in reality, there were so many movies that has really high rates, but end up failed to make a big hit in the box office. So we're trying to solve this problem for investors and publishers and help them to predict how much profit the movie will make and whether this investment is a wise investment to make. So in order to predict the profit of the movie, we think the most important features in the database is Facebook likes and budget. For Facebook likes, it is obvious that if the cast is famous and their fans group are bigger, there are likely to be like more people walking to the cinema just for the cast and to watch the movie. And the second reason is that budget is also a very important feature, since movie with higher budget can afford more resources in filming setup, special effects, OST, etc. And they will also have more publishing fee and let more people in the world to know about this movie and have interest in the movie ultimately. So in order to predict this, we use linear regression, and all the features we use to predict the profit are all numeric features, so we're not doing any encoding kind of stuff. We're just using the clean database and dropped all the null values to do this. And the model result in 35% of success rate with cross-validation. For the model, I include cast Facebook likes and movie Facebook likes and budget as the features. Later, I did another version of the model and did a little bit of feature engineering to it so that I add the numbers of critics' reviews as a feature, and the accuracy rate bumps a little bit, but it's still in the 35% range, so it doesn't help very much. And I think the biggest constraint is that we don't have enough information for the movie before the release. So if we can include the feature like the actual rate of the critics' review will be better, since we'll have a sense that whether the movie is a generally good movie or not so good. And this can also affect the possible profit and box office sales as well.
Now, it is very important for us to acknowledge the value of our project. Why is our project important? Well, our project is very important because of the fact that as people in the modern era are becoming more and more busy, we only have so much time and money to spend on entertainment and relaxation. So with that time, it'd be important to use it wisely. So if we can find a way to maximize the enjoyable experience within that small time frame and save people money in the meantime, I think that would be very important. I think that wraps up our project. Thank you for your time.